Hello guys. So today we are going to solve good problem Koko eating bananas, problem number 85875. So this is the problem. Let's discuss it. It's a medium level problem. So the problem is problem statement is Koko loves to eat bananas. There are n piles of bananas. The ith pile has piles I bananas. The guards have gone and will come back in h hours. Okay, so what it is saying is you have given a piles array here. Let's so we have piles of bananas. Piles, you can say, let's say you have bags of bananas. Let's say for easy understanding. So each bag has this number of bananas. First bag has 3, then another has 6, and some has 7. Right. So these are the number of bananas each pile have or each bag has. Okay. And this is the h is equal to 8. Now the guards are guarding these piles of bananas, but they have gone for some work and for h hours. So this is the hours for the you have time. This is the hours for which the guards are gone, right? So this is also the time limit you have to eat these bananas. Okay, now Coco can decide her bananas per hour eating speed of k. So Coco is going to decide her speed, which is k. What is speed? Bananas per hour. It means how many bananas she can eat in an hour is the speed, which is the variable k. Now each hour she choose some pile of bananas and eat k bananas from that pile. So let's say in she is eating the speed of Coco's to eat bananas. Let's say for one banana in 1 hour, right? It means she can eat one banana in 1 hours. If the pile has less than k bananas, she eat all of them, right? Instead, will not eat any more bananas during this hour. So don't one. Let's say three is the three bananas per hour is Coco's speed, right? So she can eat 3 bananas per hour. So if here you can see 3, right? So she can eat. So what is the problem? It is saying that if there is a pile, or let's say if there is a bag which has less than 3 bananas, because right now we are setting it Coco's speed to 3. So if Coco's speed is less than 3, oh sorry, bananas in bag is less than 3, then she will eat the all the bananas in 1 hour, right? Of course, if her speed is 3 bananas per hour and there are only two bananas, so she can eat them in within before 1 hour. So there is some time left, right? If she eat it with the speed of 3 bananas per hour, then there some time left for her, right? So in that remaining time, she will not go to another pile to eat the other bananas. No, we will consider if she eats 2 bananas in 1 hour or she eats 3 bananas in 1 hour. Her speed is 3 bananas per hour. Uh, if she has left some time, we will not consider, or we will not. She will not go to the next pile. I will explain you. Okay. So okay, let's create a new board. Okay, what is saying is like we have she had some bananas, let's say 3. Okay, okay, she had 3 bananas, then she had let's say 2 bananas. I am going to change the parameter. Then she had 7 bananas, and then she has 19 bananas, I'm going to say, right? Okay. mm, so and her speed is 3. So I'm going to, let's change this. Okay, make it like this, and this is the array, right? Let's differentiate this. Okay, and her speed is 3. So if I come here in 1 hour, in first hour, h is equals to 1. This is the h. She eat 3 bananas, right? Right. So entire hour is utilized because took the speed of Coco's is 3, and C eats exactly 3 bananas in 1 hour. Now in second hour, another 1 hour, right? C eats these 2 bananas, right? If she eats these 2 bananas, sometimes left, like let's say around 20 minutes, she had left with 20 minutes, right? So in 20 minutes, she will not go to this or eat this banana from this 7 piles of 7 bananas. No, we will consider she took whole of 1 hour to eat 2 bananas, right? So what we will see, so to the in first hour she eat 3 bananas. In second hour, so total time taken is, this is the total time taken, which is 1. Now in second hour she eat only 2 bananas, but we will consider it to be a whole, right? So we will say it, see if she will use entire 1 hour, right? Will not use the remaining time for another pile, so it means she takes the, now here is 7 bananas in another hour. Now we have 7 bananas. Now 7 bananas, she is eating with the speed of 3. So how many times she will take to eat the 7 bananas? So for the first 3 bananas she will take 1 hour, then for another 3 bananas she will take another 1 hour, which is total 2 hours, and now she is left with 1 banana, which again she have to start with another hour. So if I technically I think she would take 2 hours and 20 minutes to eat the 7 bananas, but again I say we will not, you going to use the remaining time of an hour in for another pile, so we will say that she will take almost 3 hours. In first hour she will eat 3 bananas. In second hour she will eat 3 bananas, and in the third hours in third hour she will eat only 1 banana, right? So total she will take 3 bananas to eat this 7. Again, if I do the same for 19 bananas, then what will be the count? 19 going to be divided by 3, 6, 7 hours she is going to take, right? If you calculate, this is the 7 hours she will take to eat these bananas. So total time taken to eat bananas from all the piles are this, some of these hours. So 7 plus 3 10 plus 1 11 plus 1 12. So total time taken to eat all the bananas from all the piles is 12 hours, but guards are gone only for 8 hours, right? So if it means she has to increase her speed in this case, right? Because otherwise she will get caught, right? So we have to find this speed, at which speed she has to eat so that she can finish all the piles before the guards are coming, right? So what I will do is I will change this 3 to 4, right? And then do the same calculation again for 4. Then we will do it for 5, and then we'll see increase the speed, right? So this is how we will check, how we will check what and we calculate the sum of hours, and if that hour is less than 8 or equal to it, it means she can finish it before the guards are coming, right? So this is what we have to find, at which speed we have to she has to eat to finish the all the bananas from all the piles before guard comes back, right? So there are two ways to do this, right? One is linearly check the what I mean. I will tell you. Okay, so we know that how we can check is I said 3 randomly. Then I said I thought my mind, okay, I am going to increase her speed by 1. So I randomly increase the 1, then set it to 4, then set it to 5, then set it to 6, right? So I can set her speed to 1, I can set her speed to 2 bananas per hour, right? So I can change the speed of her speed of eating bananas, right? So I will start from 1 and goes, but for how far I can go, right? So I'm first of all, two things I can see here. I can go one by one from 1 2 3 and so on, and not till infinity. There is a limit. What's the limit? I will tell you. What if she eats 11 bananas per hour, right? So she will take 1 hour to eat the 11 bananas, and of course 1 hour to eat the 7 bananas, and of course 6 hours to eat 1 banana, oh 1 hours to eat 6 bananas, and again 1 hour to eat 3 bananas. So if C eats at the speed of 11, C can eat all the bananas within 4 hours, okay, which is less than 8. So yeah, this can be the answer. But again, we the question says that we need the minimum time. So I mean minimum speed. So speed is 11. Now set to the 10. If I set speed to the 10 again, if I set speed to the 10, she will take uh, 2 hours to eat the first this pile, and to 1 hour to eat the this pile, 1 hour to eat the this pile, then 1 hour to eat the this pile, then in total 5 hour, which is again less than 8 hours, right? So this can also be the answer. So right now I can see I have there are two possible answers. One is 5 and another is 4. But we have to return the minimum speed. So for 5 hours we have the less speed, which is 10 bananas per hour. So then I will decrease the speed, right? I will set the 9 bananas per hour speed. Then again I will decrease the speed, set it to 8, then will goes to 7. So one thing I know for sure, the maximum speed, right, is the maximum of this array. Look, it is possible, right? I mean, if she hits the speed of 11, which can be the maximum speed, right? Which is the she will finish the all the bananas within 4 hours, right? So I can say that the speed, that maximum speed can will be the max of the this piles array, right? So we can check start checking from 1 2 3, and it will go up to 11, right? In my example it will go to 19 maximum, right? So this is the 1 2 3 4 5 6, and it will be till 19. I have to check. So how I'll check is I will do a linear search. I will create a for loop, which is first check for 1, then for 2, then for it will check for 3, and it will go for till 19 to check which is the minimum. If it finds the answer for 3, of course 3 is the minimum speed, because less than 3 is not possible. So it will return 3. Then if not 3, then it will go 4 5, and whatever the answer, the question, our solution is, will return that answer. So I'm going to write the solution for this. Okay, so I'm going to find the max of piles. Okay, not n, let's set it to max of piles. Take a max speed, I can say max speed will be max of piles, right? And for I in range 1 2, what is max speed? Max speed, let's say plus, we have to add plus 1, because the this is the not inclusive, this is exclusive, right? So we have to do it like this. For I in range in 1 2, what is where the whatever the max speed. Then we will check is what we will check, total time taken. Time taken, I can say total uh, time taken, let's say, ठीक है ना? To eat all the piles of bananas in that hour. What is this, this range? This is the range of speed, right? The Koko has I'm going to set it to k. Now you can understand what is k. So this is k. First we are setting k to 1, then we are going to set k, then we are going to set k to 2, then 3, and this is the last value. Let's create a time taken function. Time taken function is equal to, okay, I'm going to create a helper function, def total time taken, and it is going to, of course we have to put self here, then array, and then k, we need the speed, right? And total r is equals to 0, n is equal to length of array, right? And उसके बाद then, okay, let's stop here. Now we are going to tell this, what it will return in, it will return total time to finish all the piles if this is the set of pile and this is her speed, Okay, so I will call it self dot total time taken. Mm, and I'm going to give it the piles, my pile set, right, piles array, and then speed, which is k, right. It will give the answer to us. And how it will do the calculation? Simple. uh, for I in range of n, which is going to do total h plus is equal to math dot sil. Okay, oh sorry, ceil math dot ceil array of I divided by k, right. And at the end it will return total h. It's this calculation is very simple, I will tell you. We are eating the, so if c is eating the at the speed of 2, so what it will do, array I, that is 3 by 2 is equal to 1.5, and mat dot seal will round it off to forward, right. So it will convert 1.5 to 2, oh sorry 2. So this is what we need. We are going to no, we are not going to what I'm saying, we are not going to use the remaining half hour. We are going to use the whole hour. We will consider this 0.5 as a whole hour, so that's why we are using math.c, which will convert this 1.5 into 2, right. And similarly this will do the calculation, add the hours and return the total hours. So if this total time taken, okay, let's change the variable name little bit. Time, if total time taken, if I will say if total time taken is less than is equal to h, we are going to say return, okay, else what, else it will go it will go forward. Now I'm going to run this function. Look, so I don't need to, because I'm starting from the minimum, that is 1, right, and going to the maximum. So that's why if the point at which I found that the time taken is less than or equal to h, I will return the answer, right. And there will definitely be answer, right. So this is the first case, but this is what's the time complexity of this approach. If I discuss the time complexity, first it is doing this thing in how many hours, I mean how I can say, second, okay, to travel this thing. Okay, one second, let's come here first. So here it takes order of n time to, because it is traversing the entire array, so I'm going to order of n, right. It is traversing this entire array, so I'm set it to order of n. Now this function is calling iteratively inside this outside loop, right. So we have to multiply here, multiply, and what's the time complexity of this one is order of max of what is the max, or we can say maximum element, right. I can say it's maximum element, it's 11. So this is the time speed. Now as I can say, we are traversing here, I mean this is sorted, this range is sorted from 1 to 11, it is sorted 1 2 3. So why I can't use binary search here for this scenario, right. So if I use binary search, I can reduce the time, I mean my time complexity, right. So if, because this is sorted, right, I can see here we are traversing in a sorted range. So okay, let's apply the binary search. How I can apply the binary search, will tell you. So to apply the binary search I mean binary search, we have in binary search we are not going to start from 1, we're going to start from mid, right? So let's set the low, which is our always first, and high going to be HIGS, max of files, right? This is going to be high. uh, we set the two pointers. Now little modification, while low is less than equal to high, this is our basic condition. We are going to calculate the mate, which is low, low plus high by 2 floor. We are not going to use uh, point values, float values, right? So we are using flow division, which is how we do this in Python. We got the mid. Now time taken function, we are going to say okay, find the time taken for this mid value, right? This is the mid for in our case, k in our case, right? We are not going to search it from 1 to 2, but in this scenario I am starting from minimum, right? And at the point I found the total time taken is less than the given hour, I returned. But here I'm not starting from minimum, so how I can decide which is the minimum one, right? So I have to define a variable, uh, float nf. This is the positive infinity. This is how we assign a positive infinity to the value, right? So we are going to assign k a maximum value, right? Now what I'm going to do is, if time taken is less than equal to h, I know one thing: time taken is the less than equal to h. This can be my answer, but one thing is that there can be a even less k can be even more less, right? Because we are not starting from the minimum. So how I can do that? I will set this to mid. I'm going to say k to mid, and I'm going to say hi, you come down, set to mid minus 1, right? Set the range on the, I let's say this is my mid here, 7. So for this I found the answer, of course, but I can found answer even lesser for even lesser speed. So I sort my range. Oh, this is not the array. Look, so in this case my mid is, let's say, 5, right? So if 5 is my mid, I found that at the speed of 5 I can eat all the bananas. But what if I can eat all the bananas at the speed of 3? So that's why I'm set my height to the mid minus 1 to check in this range, because this can be the answer. This is fixed, right? I'm not going to going above this, because this is the minimum speed in my sense. I'm going to check for less, not for more. So that's why I decrease the height. Else, if time taken is not, then one thing is sure, we have to increase our speed, right? So we are going to see for larger values, right? So what I will set my load to mid plus 1. Okay, this is how we are going to do. And at the end we are going to say return k. This function will be same again, and I'm going to remove this, and let's comment this out, otherwise it will throw error. Okay, run this function. Look, this is the answer. All the test cases has been passed. What will be the time complexity here? So as I can see, this function is same here, right? This function is same here, so I'm going to say order of n, which is same, right? Order of max element, this is the speed last time. Now what I'm going to do, order of logarithmic of max element. So right, let's say it like this. Okay, this is the speed in this case. Now look, that was map before, it was max element. Now it is logarithmic of max element. Now if I do submit here, it will pass all the test cases. Do the submission and it pass the test cases. Very simple.